are any issues in the topics which people have dealt till now? Any issue with any of the topics? Module 1 is done completely. Module 2 is done. Module 3 is done, and Module 4 is also completed. Correct? Any issues with any of the topics? Huh? If people have any issues with any of the topics, let me know. I'll try to cover it. Fine. And what about the status of your lab videos? Huh? What is the status of your lab video? Are you all going through the lab videos? Please respond. How many of you are going through the lab videos? People can unmute and speak. If yes, say yes. If no, at least say no. What's right? Understand. Am I audible? Already lab video status in today. And people can lower their hands. Those who have raised their hands. Huh. What is the status of your lab videos? Hello? Have you at least gone through it?
Yes, sir.
Yes, sir. Huh. Correct hit rate. See, lab videos are meant for you, fine. And personally speaking, probably you people coming to lab and getting out, having an exposure to how the kit works, how to do the connections. Everything has been displayed in the lab videos, fine. So I expect everyone to go through like lab videos and get inference about what all lab experiments people have, and go through it. It is already being uploaded in the Microsoft Teams and even in the YouTube channel. Yeah, is that so that you are not finding the link? Huh? Are you not finding the link? Is that the reason for not
No,
watching the
sir.
videos, lab videos? Huh?
There is no link, sir.
There is no link. There is no link.
We are not getting the link, sir.
May I know who is speaking?
Sir,
Sneha.
Sneha Wag.
Okay. What I'll do is today probably within 1 hour or something I'll try to upload the Excel sheet which has list of links in a serial manner of all the videos of all subjects. Fine. Is it okay? It is in a serial fashion. Fine. Even if you have lost some, missed some class, or if you miss some lab videos, and all of them are there available. Fine. You can go through it, and you can directly clicking on the link, you can browse, and you can go through the lab videos. Is it okay? I'll send you the Excel sheet. Using that Excel sheet, you can find the link and you can get it done. Fine. And that Excel sheet has a subject code and subject name, everything. Fine. So I'll try to send it in the group. Is it okay? Hopefully that will help sort your problem. Correct?
Yes, sir. Yes, sir.
Okay, fine. Okay, fine. So now, so coming to the implementation part, I would like to discuss regard. I will not in this class. I will not start with anything for any fresh topics today, since already time is somewhere around 9:30. I will just try to memorize what all contents we have covered in the last class and how to go further with the implementation of what you call serial address accumulator. So this is a serial address accumulator. How actually people have already learned multisim, right? All of you. Yes or no?
Yes.
Yes, sir.
add-on course attend ಆಗಿರ್ತೀರಿ ಎಲ್ಲರೂ?
Yes, sir.
Probably currently person is handling the add-on course, correct?
Yes, sir. Yes, sir.
And people are accustomed to what you call multi-sim tool,
Yes,
how
sir.
to use, how to get the components, how to connect them, and how to get the output. Is it yes or no? Correct.
Yes, sir.
So
Yes, sir.
in serial address accumulator, when I if in serial address accumulator, what is the content? I have to implement this thing. Correct. Forget about the control circuit. How to implement the control circuit? I need an explanation about how are you going to implement. I just want to know how exactly people are thinking of implementing what you call this part in multisim. What analysis people have. So one what all things people can get directly. Hilton. What all things in multisim people can get directly here in the computer block diagram? Hmm. Speak up. Please first. I have to complete this. And I have to start with conversion. That is binary to gray and gray to binary conversions. Speak fast. Hmm.
Flip flop.
I need a flip flop. D flop. I need D flop. Correct? Yes or no? And D flop is readily available. D flip flop is readily available. Fine. D flip flop is readily available in multisim. Next one. Matin ಬೇಕು.
Adders. Full adder.
Yes, correct. Full adder, you need a full adder, correct. And even this section is available directly in your multisim as a block. Fine. Next, is there anything else which register is not available? This the main thing is you don't have this section available in your multisim. You have to think on how you have to create this section and how you can depict this section, these two sections. What are the first section? It is the accumulator section. What are the next section? It is the add-in section, add-in resistor section, accumulator resistor section, and add-in resistor section, which you are supposed to implement. Correct. So how exactly people think you can implement this accumulator resistor and add-in resistor? Can anyone tell me? Can anyone brief it out? Answer if it is wrong, it's okay. If you're not attempting, that's not okay. Fine. Do make a point of attempting and do attempt it wisely. Fine. Speak up. Hang on generate ಮಾಡಲಿ register. What actually is a register? I am not asking about RESISTOR. I am asking about REGISTER. Fine. So what actually is a register? What actually is a register? ಇದನ್ನ ಅಂದೆ accumulator register ಅಂತ ಅಂದೆ ನಾನು. 4-bit accumulator register. What is this? A 4-bit add-in register. What actually is this register? Am I audible?
Yes.
What actually is this register?
Storage device.
Yes, storage device. Very good. How many bit storage device? It is a 4-bit storage device. 4-bit means what? There are 4 different values or binary values that can be stored, even in add-in and even in accumulator. Correct? So 4-bit means what? It can store 0 or 1. This can store 0 1, 0 1 1, 0 or 1, and all these 8 bits can store the value 0 or 1. Correct? Yes or no?
Yes.
Yes, sir.
Yes, sir.
And these are controlled by clock. Correct? These are controlled by clock. Correct? Now think of, imagine how can you get this thing done or get this thing depicted in your what you call implementation. Hang ready ಮಾಡ್ತೀರಿ. How can you realize these 4 bits, 4 memory storage bits? Hang realize ಮಾಡ್ತೀರಿ. In question only I'm addressing what you are supposed to use. How you are able to store this, how you are able to create this memory storing element in available here as a accumulator register and add-in register. How exactly? How exactly? Please respond. Please respond. Everyone.
Flip-flops, sir.
Yes, appreciate. Which flip flop you are thinking of using? Which is the best flip flop? Which is a handy flop which you can use for just storing a 1 bit data? Which best flip flop you have for storing just one bit of data? Hmm.
D flip-flop.
Yes, D flop. So x3 will be replaced by one D flop, x2 will be replaced by one D flop, x1 will be replaced by one D flop, and x0 will be replaced by one more D flop. Similarly, y3, y2, y1, and y0. And since is the circuit synchronous or non-synchronous? Is this circuit synchronous circuit or non-synchronous circuit? Asynchronous circuit.
Synchronous.
If synchronous, why synchronous?
Because clock is fed simultaneously to
Clock
the
is
board.
available.
Yes, appreciate. Clock is fed simultaneously to all the what you call blocks. Understanding? So now how many flip flops am I having here? I'm having 4 flip flops. So I have to feed all the clocks of all these 8 flip flops to only one clock, one master clock. Understanding? And I have D inputs. This D input should be fed to the flip flop output. This Q output of the D flop should be connected to the next D flop. Q output should be connected to the next D flop. Q output should be connected to the next D flop, and this should be connected to the full adder. Again, here, this output of the register last D flop should be connected as the input to the first D flop. The output of the first D flop should be connected as the input of the second D flop. The output of the second D flop should be connected as the input to the third. Similarly, the fourth. Getting all of you understanding?
Yes.
And the last output, again, I will feed it to the full adder, and even I'll feed it to the first D flop input. Getting? So in this way, I'll be able to what you call realize what you call the serial adder with accumulator. Is that understandable? Yes or no? Everyone is understanding
Yes,
this? Yes or no?
Yes,
So
Yes, sir.
next serial adder with accumulator ಅಲ್ಲ? So what are the how will you able to get to know that you are able to get the answer as sum and carry? How will you, what are the identifiable devices, indicators you are using in the multisim tool? Indicator ಅಂತ ಏನು ಯೂಸ್ ಮಾಡ್ತೀರಿ ನೀವು? What indicator have people used?
LED.
LED, correct? LED is one good indicator. So if you can use LED at sum and carry for determining whether, and even you can use LED in individual bit locations also to check what is the status. It is 1 or 0. Every stage you can put one LED. For every output you can put one LED, and after 4 clock pulses I will be able to get the answer as sum and carry. Is that understandable? Yes or no, everyone?
yes,
You are getting how to realize? All of you are getting how to realize?
Mhm.
And in that section, I will not design the control circuitry, because control circuit, if I put a control circuitry, it will be completely automated. I need a live demonstration of how that bit by bit processing is done, and how that values are shifted and they are fed. Understanding? So we will look into it and we will try to implement it. Fine. Is it okay? What all experiments people have studied in the Adel goes by Prasanna sir? Even implementation ಕಲಿಸಿದ್ದಾರೆ ಅವರು sir. Have you ever used the indicators and D flops in the add-on course till now? Have you used it?
Indicators are used, sir.
Flip flops are not used. Flip flops are not used till now.
yes,
No, sir.
Okay, fine, fine, fine. So we shall probably Monday another session will be engaged on me, and I'll be trying to depict how that thing works and how it can be implemented. Is it okay? Yes or no?
Yes, sir.
yes, sir.
Yes, sir.
Fine. I will straight away move to the lab session, and there in lab session I had missed one part in theory. That part is conversions. That is and I will try to explain this once on one stretch. So Ilan Madliutane ನಾನು this is the probably sixth experiment which we are dealing with. Ilan ಅಂತ ನಾವು realize adder and separator circuit using 74139. What is 74139? What is 74139? Please be fast in answering. What is 74139? What is 74139?
Dual 2:4 line decoder.
Yes, yes, it is a dual 2:4 decoder, correct? It is a 2:4 decoder, and it is having two 2:4 decoders in it, correct? Yes or no? The IC has two
Yes.
2:4 decoders in it. So two inputs, four active low outputs, correct? All the outputs are active low, and it is having one enable, that two active low enable, and two inputs, one enable with active low. Yes or no? Correct? Yes or no?
Yes, sir.
Now, what
Yes,
am I
sir.
trying to implement? I am trying to implement an adder and a subtractor circuit. So, how many adders are there? There are two adders, half adder and full adder. Correct? Yes or no? So, half adder and how many inputs are there? A, B are the inputs. What is the output? Sum and carry. So, input is 0, 0, 0, 1, 1, 0, 1, 1. What is the output? 0, 0. Sum 1 carry 0, sum 1 carry 0, sum 0 carry 1. Correct? Yes or no? So how will
Yes,
you
sir.
how would you write? What is the next step? I want to implement this in Antani half adder. 1 2:4 decoder is fine, correct? To implement this half adder, I have only two inputs, correct? ಎರಡು inputs ಹಾಕಲ್ಲ ನಂಗೆ half adder implement ಮಾಡ್ಲಿಕ್ಕೆ. So
Yes, sir.
two inputs are more than enough. I'll use only first section. I'll use only one section of 2:4 decoder, 74139. So I will give one input as A, one input as B. Understanding? So now, what is the sum expression? Sum is equal to what here? S is equal to summation
A
M
A,
of
A bar,
summation.
A bar B.
A bar B.
Now I am writing
bar
minterm
B
list. I am writing minterm list. I am writing
A
minterm list.
plus
A bar
Summation M
B.
of summation M of 1 comma 2. Am I correct? I am
Yes.
writing minterm
Yes,
list.
sir.
So it will be summation M
yes,
of 1 comma 2. And for decoder especially, you need the minterm list form of answer for getting this thing done. Correct? Now, tell me one thing. Since outputs are active low, the output terms are sum terms or product terms.
terms.
I appreciate. Very good. So output terms are sum terms. Correct. When the output term is sum term, I have to realize a equation. Is it a SOP equation or POS equation? Is this equation a SOP equation or POS equation? Summation M.
Yes, sir.
SOP.
It is a SOP equation. SOP are na?
Sum of product.
Sum of
Sum of
product.
product. Correct.
That's
Here the terms should be product terms or sum terms.
Product terms.
Product terms ಇರ್ತವೆ. ಆಗ ನಂಗೆ ಔಟ್ಪುಟ್ ಏನು ಬರತ್ತೆ? Sum term ಬರತ್ತೆ. Understanding? So, which gate I am supposed to use here at the output side of 1 and 2? ಯಾವ gate use ಮಾಡಲ್ಲ ಇಲ್ಲಿ? Is 0, 1, 2, 3. Which gate? ಇಲ್ಲಿ ಯಾವ gate use ಮಾಡಲಿ? My question is, I came to know this is the equation of the sum, that is the minterm list, summation of 1 comma 2, but the output is product, sum term which I am getting. I need SOP form. Which IC should I connect to the exit of 1 and 2 pin? Is 1 and 2 pin now on the IC connect ಮಾಡಬಹುದು. Which logical IC I am supposed to connect at the output of this 1 and 2? I am asking.
NAND gate.
NAND.
NAND.
Appreciate.
NAND gate.
I have to go for a NAND gate. So I'll be connecting a NAND gate, and this is my sum. Similarly, carry another. It is summation M of just 3. Correct? Carry is summation M of 3 because carry is 1 only for the last combination. So I'll be using one NAND gate. I'll be shorting the inputs, and then I'm feeding it to the NAND gate, and this will be my C. Is it understanding? Are you all getting this?
Yes.
So this is how we will be illustrated. This is what I have done here. Getting all of you.
yes, sir.
Yes, sir.
Understanding? Next one. Half subtractor is also done in the same way. Only just instead of A and B, A and B will be the inputs. Output will be difference and borrow. Correct? 0, 0, 0, 1, 1, 0, 1, 1. Difference is 0, borrow is 0. 0 minus 1, Difference is 1, borrow is 1. Difference is 1, borrow is 1. Difference is 0, borrow is 1. Borrow is 0. Correct? Yes or no?
Yes, sir.
Yes, sir.
Yes.
Hopefully I am right or wrong. 1 minus 0, 1, 0. Difference is 1, borrow is 0. 1 minus 0 ಅಂದ್ರೆ 1 minus 0 is 1. Difference is 1, borrow is 0. Correct? So ಇದಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ ಮತ್ತೆ difference ಒಂದು summation m expression ಬರಬೇಕು. Difference is what? Summation m of 1, 2. Same as half adder. Borrow is what? Summation m of 1. So at pin number, I will tell you how the pin configuration is. There is two enables here. Enable A bar, enable B bar. This is for A set, this is for B set. There are two select lines for A set. For B set, S0 B, S1 B. Similarly, there are two select lines for A set, that is S0 A, S1 A. And there are four outputs, Y0 A to Y0 B to Y3 B. Here also there are four sets, Y0 A to Y3, Y0 A to Y3 A. And there is supply and there is ground and VCC. Understanding? All of you understanding?
Yes, sir.
And
Yes,
since
sir.
Yes, sir.
I'm implementing a half adder and half subtractor, I'm using only one part of the IC. I'm not using the rest part. This is not needed. Understanding? Now, full adder. ಇಲ್ಲಿ full adder use ಮಾಡ್ಲಿದ್ದೀನಿ. Full adder has how many inputs? Full adder has how many
Three
inputs?
input.
It has
Three
three inputs. But how many inputs 2:4 decoder has? It has only two inputs. But 74139, it has how many inputs? How many 2:4 decoders? It has two 2:4 decoders. So I have to connect. I had to convert this 74139 in such a way that I have to get three inputs. How can I do so? Hang ಮಾಡಲಿಲ್ಲ ನಾನು ಮೂರು input ಬೇಕು. I have to get one more input somehow. How will I get one more input? It is having two inputs here. It is having two inputs here. I will short A and A, B and B. I need one more input. How will I get one more input? I need A, B, C as the inputs, right? Is my point very clear? Are you getting me?
Yes, sir.
Full adder has how many inputs? Three inputs. So how many outputs are possible here? There are 8 possible outputs, 8 combinations of output. Yakandra ABC andra 3 8 combinations. So I need to use all the pins, all the output pins first thing. And there are two inputs here individually. I have to merge this to form this as a 3:8 decoder. ನಾ ಏನು ಮಾಡಿದ್ರೆ 2:4 decoder ನ 3:8 decoder ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ನಾ ಏನು ಮಾಡಲಿ? Respond first.
Connect third input with NOT gate.
Connect third input with NOT gate and give it to enable input. Correct? This enable, if I connect it to one more enable with the NOT gate, then I can get one more input C. Yes or no? A is shorted with this A, this B is shorted with this B, and this is one more input C. So A, B, C, and I'm getting three outputs. Is that thing understandable?
Yes, sir.
Yes, sir.
And similarly, enable is shorted to this enable EA bar is shorted to enable EB bar with a NOT gate. S0 A and S0 B are shorted. S1 A and S1 B are again shorted to form A, B, C. Getting? Yes or no? And the output of sum and carry, I have written to table here. What is sum? Summation M of 1, 2, 4, 7. What is carry? Summation M of 3, 5, 6, 7. Correct? So I am using 4-bit for sum and difference and borrow. This is for sum and carry. 4-bit NAND gate. 4-bit NAND gate is nothing. 4-input NAND gate is nothing but IC 7420. So I am using 7420 IC and I am getting carry and I am getting sum. Is it okay? Are you understanding this diagram?
Yes, sir.
Similarly, this one, the difference and borrow. Adukunu nak outputs bardada 0, 1, 4, 7, and here it is 1, 2, 3, and 7. Getting? Yes or no? Are you understanding, everyone? Right.
Yes, sir.
Next, binary to gray conversion. What actually is binary and what actually is gray? So, binary to gray. How to convert binary to gray? whenever you're converting any number from binary to gray, remember one thing: the first column of binary and the first column of gray will be identical, always identical. Tilito? Understanding? Yes or no?
Yes, sir.
Yes, sir.
What actually is gray code is, whenever I am having two adjacent cells, if the adjacent cells, it is just tying the adjacent cells with the XOR gate, hung. So, ile G2 bekkanage. What actually is G2? I have to get G2, I need B3 and B2. What is G2? G2 is nothing but B3 XOR B2. What is B3 XOR B2? 0, 0, 0 XOR 0. Hit it. 0 XOR 0. 0 XOR 0. Speak faster. 0. 0 XOR 0. 0. 0 XOR 0. 0. 0 XOR 0. 0.
0.
Next. 0 XOR 1. 1.
1.
0 XOR 1. 1. 0 XOR 1. 1. 0 XOR 1. 1. Next. 1 XOR 0. 1.
1.
1.
1 XOR 0. 1. 1 XOR 0. 1. Last 1 XOR 0 and 1. Last 4 sets are 1 XOR 1s. So I am getting 4 zeros here. Getting? Yes or no?
Yes.
Now, to extract G1, G1 is nothing but B2 XOR B1. What is G1? It is extraction of B2 XOR B1. 0 XOR 0, 0. 0 XOR 0, 0. 0 XOR 1, 1. This 4 sets I am discussing here. Correct? 0 XOR 1, 1. 0 XOR 1, 1. 1 XOR 0, 1. 1 XOR 0, 1. Next, another 4 combinations, it is again zeros, because 1 XOR 1 is 0, 1 XOR 1 is 0, 0 XOR 0 is 0, 0 XOR 0 is 0. Again, I am getting 4 combinations of 1s. Getting this, all of you?
Yes.
Yes, sir.
Yes, what will be G0? What will be G0?
V1 XOR
B1
V0.
XOR B0.
Yes, appreciate. It is B1 XOR B0. Is 0 XOR 0? 0. 0 XOR 1? 1. 1 XOR 0? 1. But 1 XOR 1? 0. 0 XOR 0? 0. 0 XOR 1? 1 is 1. So in this way I am getting this combinations of 1s. Is that understandable? Yes or no?
Yes.
Yes, sir.
Yes, sir.
Can you able tell me, can this implementation, it just inputs available? I have to convert binary to gray. How many bit binary code I am converting it to gray? How many bit binary code I am converting it to gray? Yes, bit binary convert madliddana gray.
4.
4 bit binary I am converting to gray. So how many inputs are there? 4 inputs are there. Correct? Can I realize this using 74139? Can I realize 4 input system using only 174139? My question is, can I realize 4 input binary number in 139? Please respond. Yes or no? If yes, why yes? If no, why no? Hit it. Can I realize? Hello? Am I audible? Am I audible?
Yes.
Yes.
Yes, sir.
Now, here, can I realize 4 input system using only 74139? Asade Tenri, Madlik Akadana.
No, sir.
Why? Because maximum
16
realization
combination.
ಏನದ maximum ಎಷ್ಟು ಇನ್ಪುಟ್ ತಗೋಬಹುದು ನಾನು 3 ಇನ್ಪುಟ್ಸ್ ಅಷ್ಟೇ ತಗೋಬಹುದು. 2 ಡಿಕೋಡರ್ ಅದ ಒನ್ ಎನೇಬಲ್ ಶಾರ್ಟ್ ಮಾಡಿದ್ರೆ ನಾಟ್ ಗೇಟ್ ಹಾಕಿ I can get maximum 3 inputs. ಇದೊಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾನೆ. This answer question can be answered very easily. There are 4 inputs. How many combinations of outputs?
16.
15. 0 to 15 16. 16 combinations ಅದಾವ. Do you have 16 output pins in 74139?
No, sir.
No, sir.
How many outputs you have in 74139? Only 8 outputs.
8.
That's why you cannot implement this entirely in using one 74139. Understanding? Yes or no? So instead, I will take only this section. Yeah, section na? B2, B1, B0, and I will implement this only G2, G1, G0 section. Understanding? Yes or no? What is G2?
Yes, sir.
What is G2 till here? I have drawn a black line here. Fine. So what is G2? Summation M of 4, 5, 6, 7. Correct? What is G1? Summation M of 2, 3, 4, 5. What is G0? Summation M of 1, 2, 5, 6. Correct? Yes or no? Yes or no?
Yes.
So in
Yes.
that
Yes,
way,
sir.
we are going to implement what? You'll note. This is what I have implemented. The implementation looks like getting. So this is G0, this is G1, and this is G2, and this is the truth table for it. Getting? Understanding?
Yes,
Yes
sir.
or no? Actually, we should
Sure.
write here summation M.
Yes.
This is summation M. This is summation M. Understanding? All of you understanding?
Yes, sir.
Yes.
Yes, sir.
And ulta, gray to binary. I will tell you what this diagram specifies. You'll note it. First column will be the same. ಹೇಳಿದವಲ್ಲ? First column is same.
Yes.
What is G2? What is G2? B3 XOR B2, correct? That's why I have taken B3 and XORing with B2. What is G1? B2 XOR with B1.
Absorb.
What is G0? B1 XOR with
B1
B1 exam.
B0. ಆ ರೀತಿ. Getting? So similarly here, gray to binary code. Again, the first principal element will remain the same. ಯಾವುದು? First column will remain the same. G3 will be same as B3. Understanding? Now, what is B2? What actually is B2? B2 is G2 XOR what here?
G1
ಇಲ್ಲ ಇಲ್ಲಿ ನೋಡ್ರಿ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಇದೆ ಈ ಆ್ಯಂಡ್ ಇದು ಎಕ್ಸಾರ್ ಗೇಟ್ಗೆ ಒಂದು ಇನ್ಪುಟ್ ಇದೆ G2 ಅದ ಇನ್ನೊಂದು ಇನ್ಪುಟ್ ಏನದ G3 ಅದ or B3 ಅದ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ so it is what is B2? B2 is what? G2 XOR
G2
G3.
G3.
Understanding? What is B1?
G2
G1
cross
XOR
G1
G2.
G2
B1 exam.
G1 XOR B2. What is B0? G0 XOR B1. Understanding? So in this way, first column will be remaining the same here. G3 and B3 will remain the same. So what is B2? What is B2? It is, what is B2? What is B2 here? Another B2. G2 XOR G3. Correct? Either G3 and then talk about it, B3 and then it will be better for you. So G2 XOR B3. Fine. 0 XOR 0? 0.
0.
0 XOR 0? 0.
0
Next, 0 XOR again, you'll note there are 4 bunch of ones here and there are 4 bunch of zeros here. So I'm getting 4 bunch of ones here. Getting?
So,
Yes.
Ille 4 bunch of ones. Ille another 4 bunch of zeros. Here there are 4 bunch of ones. I'm getting 4 bunch of ones here. Getting? Understanding?
Yes.
Next,
yes, sir.
B1. What is B1? It is G1 XOR B2. Correct? It is G1 XOR B2. Correct? So G1 another, 0011 other, another 0000 other. So I'm getting 0011 as the answer. 0000 XOR is 00. 11 XOR with 00 is 11. Next 00 XOR with 00 again XOR with 11 is 11. You are understanding?
Yes, sir.
B1 is G1 XOR B2. Hanga. What is B0? Similarly, it is G0 XOR B1. It is G0 XOR B1. Will give me B0. Getting? You'll 0 1 other, you'll 0 0 other, so I'm getting 0 1. You'll 0 1 other, you'll 1 1 other, so I'm getting 1 0. You're understanding this way I have moved on to the sequence. Is it okay? Yes or no?
Yes, sir. Yes,
Yes.
sir.
So 1 1 1 ends here. What is G2? What is B2? B2 is again summation M of 4 5 6 7. B1 is summation M of 2 3 4 5. B0 is summation M of 1 2 4 and 5 6. Understanding? And it's not 5 6, it is just 5. 6 is not available. Understanding? Is it okay? Are you understanding?
Yes, sir.
ಈ ರೀತಿ
Yes, yes.
I will be completing the implementation of grade 2 pantry also. And this grade 2 pantry I have not shown here. Obviously, you have to do it on your own. And it will be looking like the same thing, only the connections will be misplaced, and instead of G0 and G1 and G2, I'll be having V0, V1 and V2. Is it okay? Yes or no? Did you all understand the conversion of binary to gray and gray to binary? E questions anna, these questions are even pertinent to your theory. So in theory, if they ask you convert gray to binary using 74139 decoder or binary to gray using 74139 decoder, you should be in a position of writing it. Is it okay? Yes or no?
Yes, sir.
Yes, sir.
Thank you. So thank you one and all. We shall end the session
Thank
here.
you.
In the next session, I'll be
Thank-
dealing with next session will be add-on session. I'll be dealing with multi-sim, and later on I'll be dealing with the other rest part of your module 5. Is it okay? Yes or no?
Yes.
Yes, sir.
Yes, sir.
So,
Today attendance is